Hello everyone and welcome on today's video. My name is Wouter Peer and I'm the founder and main developer of GG2 Cloud. And today we will be discussing individual and collective borefields and which one is better or more nuanced, what are the advantages and disadvantages of having individual versus collective borefields. Now, if we think about geothermal systems, we can categorize them in one of three ways. So imagine you have an apartment building or you have a newly built neighborhood, something where you have multiple users, multiple buildings, multiple units, and each of these units in blue has its own production unit for HVAC, in this case a heat pump. Then we have an option where we can say, okay, each individual unit has its own production and this production is coupled to an individual borehole or an individual borefield. So this is a 100% individual solution. Next, we can say, okay, we have different units, different users. Each of them have their own production unit, but we will couple them on a collective borefield. So here, the borefield is collective, but still our production units, our heat pump, are individual. And then the last solution is to go full collective, where we have again our four different users, apartments, buildings, does not really matter. We couple them to a central heat pump, even if you want in combination with a heat exchanger for passive cooling. And this collective production unit is then coupled to our borefield. So we have both our production and our borefield centrally. So these are three different types of geothermal systems we will be discussing today. Now, there are different viewpoints on how to look at collective versus individual systems. What we will not cover in today's video, because we have already discussed that in the past, is the advantage of having a collective or general geothermal system versus individual air-to-water heat pumps. We've discussed that earlier when we were talking about the advantage of geothermal systems in general. It's linked in the description below. Now, what we will be looking today at is the difference between the three types when it comes down to geothermal design. Looking at peak powers and imbalance, and also some general aspects like what can we say about the costs, what can we say about the maintenance, and are there some societal implications of the designs we opt for as a geothermal design. So let's start with our first option, having an individual borehole per apartment or per house. And this is something I, in my daily job, see more and more occurring, that you have an apartment building, 4 users to 10, 20 users, and each of them has their own heat pump, each apartment has their own heat pump, and it's coupled to an individual borehole. And the same you see with neighborhoods where each different house has its own geothermal installation. For example, in the Netherlands or in Sweden, this is well common. Now, the problem with this, or the consequence of this design choice, is that each borehole, each borefield, should be able to cover 100% of the peak load of its user of its building. Now, that's the advantage, that you should cope with 100% of the load. But on general, when you have these individual systems, the borehole spacing is also typically larger. Which means that, which we discussed 2 weeks ago, it's easier to cope with imbalance. But the problem is that even if you have individual systems, all those systems still interfere with each other. So it's the interference that we still need to take into account. And to go a little bit deeper on that is, as we discussed earlier, interference is the name for different systems, neighboring systems that have an effect on each other. And this is caused by the imbalance. And this one is again determined by the building demand. So what basically happens is, if your neighbor has a geothermal system and it's extracting heat from the ground year after year, that will cool down the ground on his property, but also on the neighboring properties. So your borehole or your borefield will experience a slightly different ground temperature due to what your neighbors are doing with their geothermal system. And that's called interference. And the closer the systems are together from your neighbors, the bigger this interference will be. And here we want to make a difference between apartment and houses. Now imagine you have an apartment building with 10 different apartments, very small footprints, and each of them has their own different individual borehole. Then all the boreholes are rather close together because it's cramped on this small space, small footprint of the apartment building. Whereas if you, for example, have a neighborhood where 30 new houses are being built and each house has their own individual borehole, here the boreholes are way further apart. So the situation depends a little bit on whether you're looking at apartment buildings or houses, because the borehole spacing is important for this interference. And just to show you, if you have one house with a particular borehole depth, you can design it in such a way that you end up with a good temperature point, 41 Celsius in the long term. But if you, for example, say, okay, we have 8 houses around us, we have 9 houses in total, having the same design will give you minus 0.88 degrees Celsius. So it's so the case that if you have an individual design, you still need to take into account this interference, because especially if your boreholes or your neighbors are close, this will lead to significantly different results. So what can we say about individual boreholes per apartment or houses? Is it cheaper? Well, it depends. So on the one hand, we have a high resulting peak power, because each geothermal system should be able to cover 100% of the peak load, and there is no simultaneity. Each system has its own user, no simultaneity. But a potential advantage is that we have a lower influence of imbalance due to borehole spacing. Since we have individual buildings, on general, I could say, are the boreholes further apart, and we need to take into account this interference. So we have two counterbalancing effects. So we need to evaluate this case by case. And I would say, as a general rule of thumb, for neighborhoods where you have all separate houses, probably it's cheaper to have an individual system. Because boreholes are far apart, interference is slightly lower. And for an apartment case, it's probably more expensive to do it 100% individual from a geothermal point of view, because your boreholes are very much together and there's quite a lot of interference. When it comes down to a maintenance aspect, we have quite a high maintenance, because if we have multiple systems, multiple heat pumps running, there are also multiple systems that require maintenance. So cumulatively, we have a higher maintenance cost. And from a societal point of view, since we have multiple heat pumps, each covering 100% of the peak demand of the building, the cumulative peak electricity power on our grids is also high. We have more installed capacity. So this puts more stress on the societal aspects of your own system, namely the electricity grid. And on general, we also have an oversized system, because each geothermal system on itself should be able to cover the load from the individual user, the house or the apartment. So we have, on general, an oversized system. Now, if we then take a look at a slightly more collective option, where we still have the individual production units, but we now have a collective borefield. Now, we have the advantage that since we now have a collective part, a collective geothermal system, we have a lower resulting peak power, because we have simultaneity between the different users. Not all users demand heating and cooling at the same time. So in general, if you have 20, 30, 40, 50 users, the peak power will be lower on your borefield. Now, if you have not watched the video on simultaneity, it's linked in the description as well. Now, for this particular type of geothermal system, I want to make an extra nuance. Because, yeah, heating and cooling is not simultaneous, but what about tap water profiles for your domestic hot water? You can say that there is simultaneity, but in the end, most people shower in the morning or in the evening. So there is quite a high overlap in tap water profiles. And also, what do you do with smart price adaptation? Because nowadays more and more heat pumps are intelligent and they tend to follow the electricity price. So if you have at one moment in time a very cheap electricity price and all your heat pumps have smart price adaptation, chances are that they will synchronize one way or another, and they will put a high peak load on exactly the moment where your price is the lowest. So when it comes down to this type of solutions, in the past I would say there was quite a lot of simultaneity, but now you really have to think about this overarching control mechanism. How do you make sure that your heat pumps are not synchronizing based on tap water profiles or smart price adaptation? Now, in general, since we now have a collective bore field, the borehole spacing is smaller. We are not going to make boreholes or bore fields where the boreholes are 20 meters apart. That's just not economical. So they are closer to each other, which makes it harder to cope with imbalance. But there is an upside to this, because we now have a central collector, a central manifold where all our boreholes come together. We can also work with regeneration. We can cope with this imbalance working with regeneration. And this we also discussed last week. So if we have a central bore field, we can work with dry coolers, solar absorbers, etc. Now, the nuance I want to make with this is that it's not trivial to do so, because we do not have a central control system. So typically in this type of geothermal system, we have a bore field, which is a passive component, and the different controls for heating and cooling are in the individual apartments or houses. And there is no central control system that could be used to control our regeneration with a dry cooler solar absorbers. So if we would use regeneration in this case, we would need an extra central control mechanism specifically for this regeneration. So yes, it's possible because it's on the same manifold, but it's not trivial to do so. It's not plug and play, let's say. So in general, is this a cheaper geothermal system? Will this give us a cheaper geothermal system? Well, yeah, we have the advantage of having a lower resulting peak power, but it's not sure. So I would say that it's almost the same as in our last case. We have a higher influence of imbalance because we have this lower borehole spacing. So also here we need to look at it from a case by case. Again, from neighborhoods, it's probably not cheaper to go for a collective systems. And for apartments, probably. Again, since in the individual case, your apartments or your boreholes were already close together, and putting them on the same manifold will not change their spacing quite a lot. So the imbalance effect is not that different from this case when compared to the previous one. But we could have a lower resulting peak power, resulting in a lower total number of boreholes. Related to maintenance, we again have a higher cumulative maintenance cost because, yeah, in the end we still have the same number of heat pumps, we have the same number of users, so also the same number of maintenance. And from a societal point of view, also nothing has changed. We have still a higher electrical peak power on the grid because of our installed capacity. And I would say that on general, this also leads to an oversized geothermal system. Because, yeah, we can take some simultaneity into account if we're cautious, but there is not an easy way to do regeneration. It could be done, but it's not trivial. And secondly, we cannot be sure how our simultaneity will really behave. So if we then take a look at our final solution, our final type is where we have everything collective. So we basically have district heating or cooling grids, or for a neighborhood and in the apartment building the same. So we have different users, central production unit and collective field. And the advantage here is that we indeed have simultaneity. So if we have 100 users connected to the same heat pump, this heat pump is typically sized to cope with 80% or 70 or 60% of the total heating and cooling demand. And since we now have a single heat pump, which is designed in a certain way, we know for sure that there will be no higher peak power on the ground and we have real simultaneity. Now again, here we have still a central bore field, so our borehole spacing is smaller, it's hard to cope with imbalance, but we can still work with regeneration. And here, because we already have a central plant room where our heat pump and our heat exchanger is located, it's easier to embed this regeneration because there is already a central control mechanism. So that makes this solution really interesting. So is this a cheaper geothermal system? Well, now we have for sure a lower resulting peak power because we really have simultaneity, because it was taken into account when we were designing the heat pump itself. We have a higher influence of imbalance, right? Just like before, but now it's easier to optimize it because we can do regeneration, because we have a central plant room and we have a central control mechanism. But yeah, is it cheaper? Again, it depends from case by case. From neighborhoods, probably not. And this depends quite a lot on the region you're in. But if you're have a neighborhood, you basically are building a central district heating system. You have a central heat pump and your heat should be distributed to different uses in the neighborhood. And that's a very costly endeavor. It could be interesting, but probably not with a question mark. When it comes down to apartment buildings, the question mark has disappeared because I'm confident to say that probably having a collective system in apartments is cheaper, particularly from the geothermal design point of view. You really have simultaneity now, so your bore field is not anymore oversized, and it's easier to cope with imbalance if that's an issue for your project. Related to maintenance, having a 100% collective system is also cheaper because now your cumulative maintenance costs are lower. You just have one system. Less systems, less maintenance cost. And from a societal point of view, yeah, since we now have not an investment in installed capacity, we have also lower electrical peak power on the grid. And we have an optimized system design leading to lower societal costs. So this was all I wanted to say about these three different types of geothermal systems. Now, before we end this video, I want to stress one thing about simultaneity, because that's a discussion I had in the past before. When I say that when you work with a central heat pump, you have real simultaneity, and when you work with individual systems, with individual boreholes, you don't have simultaneity. Now, there is often the discussion about, well, these boreholes are in the same ground, so they interact with each other, which is called interference. Isn't there a simultaneity? But I want to say once and for all, there is no such thing as simultaneity in the ground. And that's because the time scale at which this interference in the ground occurs is more than 1 month. It takes more than a month from the energy to travel from one borehole to the other. And when we're talking about simultaneity between heating and cooling, it's typically in the order of hours. So it's a whole different time scale. And this is visible when we look at the G functions. So if you recall, the long-term effects are governed by G functions. You see here that there is a separation between the different borehole spacings, and the location at which are 6 meters apart, where the boreholes are 6 meters apart, separate from the other solutions, is exactly the point at which they notice each other. And as you can see in this case, it's after 1 to 2 months. So at this time scale, you cannot say anything because, yeah, the building demand fluctuates from hour to hour and not from month to month. So simultaneity in the ground is not a real thing. Interference is a real thing, but not simultaneity. So if you want to take simultaneity into account, please go for a collective bore field, but ideally for a collective heating and cooling system in general. So I hope you found this video interesting and it can help you with your next project, whether you're determining a collective or an individual system. Please share it with your friends, family, colleagues, and I'm looking forward to seeing you in our next video. Take care. Bye.